Our next speaker is Sarah Edwards, who's going to be talking about Apollo. We've already heard about Sarah today. She is a measurement of pizza. So that's we've heard that in Brian's talk. Sarah, I was talking with Sarah before. She's never presented at OSDFCon before, but is always there for these social times and stops by when it's in the greater DC area. So we are very happy to have Sarah here talking about Apollo with iOS and macOS and all things that Sarah knows very well. So welcome, Sarah.
Thank you, Brian. All right, this is my talk. It's called Go for Launch, Getting Started with Practical Apollo Analysis. So I've done quite a few Apollo presentations at this point in time, and I've never actually really gone through and say, okay, how do you get started with it? I just sort of say, hey, it's all right there, and just pummel a bunch of data at you, which apparently is perhaps a little bit too much. So all my links are down there at the bottom. The slides are already into the Discord channel. So if you've never been to one of my talks before, I talk a lot and I talk quickly and I have a lot of screenshots. So you can get some good high-res screenshots in there in case you miss a tidbit, because I'm going to be going pretty quickly. I've got a lot to get through for this particular segment. So they will also be posted on my blog's website, as well as a presentations area on GitHub as well. All right, so as far as pattern of life goes, what the heck is all of this pattern of life stuff? Well, it's how a user uses their device. What applications are they using? Where are they going? Their health, if they have an Apple Watch, a lot of that gets imported into some of this device data. All sorts of different user activities. Do I connect my device to CarPlay? Plugging and unplugging my device, using the flashlight. All of that is being tracked on Apple devices. More so on iOS devices, slightly less so on macOS, and I'll even talk a little bit about Apple TV in here as well. But for my main example, for the most part of the presentation, we're talking about iOS because it's got the juiciest bits of data. So with all of this data that's being tracked, it's all pretty much being stored in SQLite databases. Not surprisingly, mobile, Android, you might have come across SQLite databases before. So I have a bunch of queries for these. I was finding it a little tedious to go through and basically run the same queries over and over on 30 different databases. I needed to create a tool that just said, this is the database, here's the query, go for it and dump it out. I need to just quickly triage that information and output it so I can kind of poke around and do that. Now, this is truly meant for quick correlation. There is a lot of data, so it really is as much data as things like a giant log file or a giant timelining utility. It is not pretty, it's not perfect, but it kind of gets you to the main pieces of the data. I created it specifically, and I call it lazy for a reason. I want it to be a low bar to entry. So the investigators out there who are potentially able to create queries, which, some queries are very simple, some of them are extremely difficult, and every database is a little bit different. But if you can create a SQL query for whatever, and it doesn't even have to be Apple stuff. Yes, this is called Apple Pattern of Life Lazy Outputter, but what this really is it just a SQL dumper. That's it. So if you're running Android, Windows, any other platform that has SQLite databases, if you can create a query, you can use the Apollo framework to dump information from that. So I've specifically made it for SQL queries so it's easy to update and configure. So if you don't like one of my queries, that's fine. You don't have to use it. You can kind of configure it. It's very modular, and you can kind of tweak those queries to what exactly you need. It's also great from a SQL script sharing. So all of the queries are out on my GitHub. I have about at least when I put out the releases for this new version, probably about 250 queries, 250 modules, and probably about 400 or so specific queries. Queries do tend to change across the different platforms. Mac and iOS are not always necessarily the same. And then new versions like iOS 14, Mac OS 11, Apple likes to throw some new stuff in there or take some stuff away. So it's just sort of changing the query, keeping it updated. It does take some work up there, but I do like to put those out there on my GitHub site. All right, so how does it work? Well, it takes a bunch of databases, it runs a bunch of queries, puts it all into another database or a CSV, but mostly that Apollo database, and then I can go and query certain things. So I take databases, put it into a database, and do database queries with it. It's all about the SQLite database. Now, yes, one of the outputs is a CSV. I don't use CSVs, and that'll be it should not be very surprising. I like SQLite databases for better, for worse, but there is CSV output in there as well. So if you don't know anything about databases, you can bring the output into Excel and do all sorts of fancy stuff with that, or script it out, or what have you. I tried to make this as manageable as possible. But now when I'm looking at the different databases, so things like the Knowledge C. Knowledge C, I probably have upwards of, if I had to guess, 70, 75 different queries just for that database. So all these different queries, they're all selecting a little piece of something different. So what application is in focus? What is currently playing through the music app? What is this particular application usage? Each one of these has a different thing. That's why the modularity of this actually works out quite well. So that all gets sucked into what I call the Apollo database. And now I can query it. So if I'm looking for things like locations, I can look for specific items with location information. Or if I'm looking for processes, maybe I'm doing more of an intrusion investigation. I'm looking for network usage, processes, maybe certain applications associated with that, and I can go a different route there. Now, as far as what a module consists of, and again, I probably have somewhere like 250 of these. This is a single module. So there's different pieces to the module. Right at the top, we have a little bit of module metadata. Who created it, what the basic usage of it is, some of these, a lot of them that I've created, about 99% of them thus far. I try to throw in some notes in there. Yes, sometimes I skip some, so I'm working on filling out some of the documentation, so my apologies for that. But primarily want to throw in the authorship to that. So if you do want to create Apollo modules, it's literally just creating this. So I do like to provide credit where credit is due on a per module basis. A query can take 2 minutes to create. A query could take 3 weeks to create. So some of them are a little bit more complex. So truly credit where credit is due. The next section, database metadata. This is going to tell me what database this runs on. We got an example of a knowledge C query right here. So I have the knowledge C.db in there. I don't need the full path. Apollo is just going to go find all the knowledge C databases on whatever platform and just try to run it. I also have some platform and versioning information in there as well. So we can sort of tell over time, over platforms, how has this SQL query have evolved over that time. I know basically whenever Apple releases new versions, I'm going through and updating. Now these have not been updated yet. So if you are at my GitHub right now as we speak, you will find that it does not support macOS 11 and 10.14. That will change later this week. So I'm still tweaking some of the queries, but do expect some support for that a little bit later on. The next section here, query metadata. So this is going to tell me what module, what thing is this extracting from the database. So this is the knowledge app in focus one. This is basically saying what application is the user looking at. And this is cross-platform. It's showing me exactly what application. We're going to see plenty of output of that one in just a little bit. And the other pieces here, activity. This is going to give me a little kind of a human readable little activity string that I can see when I'm looking at the compilation of all this data. And then we also have the key timestamp. So I pick a timestamp. A lot of this can be done through timeline correlation. So I pick a timestamp that makes the most sense. Yes, a lot of these queries will have multiple timestamps. I try to choose the one that is most appropriate for that. So that is an Apollo module. Now, what's new in version 1.4? Again, hopefully released in a few days or so. I have now added some gathering functionality. So I'll show you a couple of the command lines for that one in just a little bit. So I can gather on my local Mac system or on a jailbroken device. It's also potentially able to gather on other platforms, but I'll be perfectly honest, I don't use Windows. I don't really use Linux, so it probably works. If you want to give it a try, please let me know in the Discord channel, and I'll throw that to you so you can be my little non-Mac platform beta tester. Happy to throw that out there. Pretty sure it'll work, but again, I haven't tried. So we have the gather functionality, and then we have the extract functionality. Extract has been what Apollo has been since its introduction 2-3 years ago. But now I want to do the gather. It saves a lot of the time. A lot of the permissions can get a little bit weird. So it just sort of says, go and grabs all these files and let me run with them. So it gives you a little bit more sanity. Overall, improved processing. I've fixed a few of the other little bugs. There's little CSV bugs in there, which I didn't realize because I almost never use the CSV side, but I improved quite a few of those. The output, I've added JSON into my SQLite output. You're going to see that in the next few slides. It just adds to a little bit more readability of the data. So the data is not truly normalized. That gets outputted from 30 different databases with 250 different queries. Each one's going to extract something a little bit different. So that JSON does help with that readability. More modules. I've already added a few more from iOS 14, macOS 11. I'm tweaking a few more. Apple loves to just change certain column names or tweak different flags in the database for whatever reason. I'm certain it's just to cause me stress, but I may be thinking about that the wrong way. So new updates for sure. All right. So a little walkthrough on the different gather functionality. I'm going to start with macOS first. And I say this is an example from macOS 11, but it's pretty much the same on older versions. So it's not specifically for macOS 11, but I just like to throw out the newest, the latest, and greatest. So the Apollo tool, it is Python 3. It now has these verbs. So gather macOS is going to gather on macOS. This is the one where I think it should work on other platforms, so I may have to rename this in the future. Certainly let me know. If it does work, here's hoping. But if it doesn't, I'm not surprised, to be perfectly honest with you. So gather macOS is going to say, hey, go get these files. It's going to use the modules directory. So all those 250 modules that I had in there, it's going to go rip those apart. It's going to say, I need this database, and this database. And it's going to go extract them from whatever path I give it on this local Mac system. So I'm just going to give it / or root and just say, give me everything. Just run through the whole file system, go find these files or these databases, and then we're going to store them into a temporary directory so we can play around with them and do some extraction of them. Now, because I'm on the root directory here, I am running this script with sudo. This is really the only time that you're going to need sudo with the Apollo script. But just because it's going through some of those system areas, it's going to require that level of permission. So just a heads up with that. And then I've also added in ignore flags, and props to my coworker Vico on this one. He kind of played around with a little trial version of this script for some stuff that we're working on. He's like, you know what? I'd really like to ignore certain paths. And once I started playing around with it, I'm like, yeah, you know what? You're absolutely right. So I've added that functionality in, and you can specify as many paths as you like. I tend to have a lot of test data scattered throughout my device, so I'm ignoring quite a few. Now, those of you on Catalina 10.15 or macOS 11, we got that fun split now between the different volumes, the system and data partition. Highly recommend doing the ignore system data volume, because the firm linking, it's actually, if you don't put that in there, it's going to grab double copies of each one of those, which is just frankly annoying. And highly recommend throwing on -- ignore to things like external NAS devices. So I had my personal NAS attached to my laptop when I was doing this, which has a lot of different data sets on there, and almost crashed my computer when it was copying all the data in there. Now, the gather functionality really should not take too long, honestly, depending on how much data that you have. So if it's running maybe more than, I don't know, I'd say 5 minutes, just make sure that you're gathering the right directories, because I've been there, I screwed up. Don't do that. So watch those mounted volumes as well, because it's just going to go find everything if you just throw / in there. And finally, once you go and do that, it's going to bring everything that it's found. It's going to copy it into this temp Apollo directory in your local working folder here. And it's just going to keep the directory structure. So it copies that into there as well. And it's going to chmod and chown all the things. So a lot of the permissions problems that were there in the previous version, 1.3 and older for Apollo, this attempts to fix a lot of that. So sometimes when you pull up a database with some of the iOS extractions, the permissions are a little bit funky. That is relatively normal, but this is just another way of getting access to that data. All right, moving on to the iOS side. So this is more of the remote collection. And even though it's local, it's still remote. This one is from an iOS 14.2. So latest and greatest. It's the device that's been check-rained. Love check-rain. It's certainly made my research a lot easier. So I am going to be using that here. So I got this iOS device. It's being tethered through a lightning cable, and I'm using iProxy to get access to the SSH server on that device. So I'm using gather iOS here, and you have to provide it the IP address. In this case, it's localhost because I am using iProxy, and my port of 4242 right there. And it just says a jailbroken device in the left-hand side there. This is where I think it could potentially be used for other remote capabilities as well. Now, when I'm specifying, it still uses that modules directory, so it still needs to run through and extract all the information from there. But the last variable here is where I want to go search for the files. So for the remote iOS stuff, it's basically just using find and SCP. So I'm just saying, go find everything under private var, which is the mount point for the data partition on iOS devices. So it's just going to go create that. It creates this iOS files.txt file, and then it just sorts through that text file and just says, okay, I recognize this one, this one, this one, this one. Let's SCP all of those to my local system. We got that there. Very much a recommendation. Use SSH keys. Otherwise, you are going to be putting your password in over and over and over and over again. And you'll find out the hard way eventually. But this is, really more or less for testing of this data. So quickly go grab the stuff from the iOS device and test certain scenarios. So hopefully it shouldn't be too much of an issue to set up SSH keys on a test device to make your life a lot easier for this. And yes, remote collection for Mac OS. I think this is theoretically possible, yet I have not yet tested it. I was this close to doing it, but just ran out of time, unfortunately. The only thing I think you'll have to change in the code is the hard-coded root. So for all iOS devices, root is the one that you want to beat, so that is hard-coded. So I would imagine you probably would have to put an admin level username in there. So theoretically it might work, but again, haven't really tested that piece. And what happens when you don't use SSH keys? Well, I did an example of this one on my Apple TV. Again, this one is check-rained. This one was running 13.4 at the time. And by the time, I mean like 2 days ago. So haven't really updated it just yet. But this is just something that you might expect if you are extracting or using Apollo to use the gather on these other iOS devices without SSH keys. So it'll work just fine. The only kicker is you just got to keep putting in your password. Every file that SCPs off the device, it's going to want to put your password in there. So just heads up, forewarning, you will definitely want to play around with those SSH keys. Just take it from me with personal experience. All right, so that was the gather functionality. That is completely brand new. Now it's the extraction. So I've tweaked the extraction a little bit, but if you've used Apollo before, it should still look pretty familiar to you. Now, one thing to keep in mind, if you did the gather and you're running the extract, remove the sudo. You really don't need the sudo. I know a lot of folks just, tab up and just run it and rechange the command line functionality, but you will not need it for the extraction process. So extract is the command. And I'm doing an output of SQLite JSON. So this is the new output that I have. It makes my life a little bit easier. So I figured I'd put it into the tool as well. And this is going to dump it to a SQLite database, but with JSON output. So it's a little bit prettier. A couple of other outputs. If you have CSV and the normal or the older SQLite version, it's going to be pipe delimited data, which is great for a quick scrolling triage, but maybe not necessarily the prettiest of outputs. So play around with it. I can honestly see doing 2 dumps of each one, and they both have their usefulness. So play around, figure out which one you prefer. And -V for version. So version, we're looking at iOS 14 here. So we got 14. And for lack of a better way of doing it, if you were doing this on your own Mac OS 11 device, yes, it's 10.16 because 11's already taken, and well, it's not smart enough to realize that. So at this point, if you run it on Mac OS 11, it's going to be looking for 10.16. I'm going to blame Apple for that one. They kind of mess everything up with my scheme. Maybe I'll make it a little bit sleeker in the future, but at this point, that's where it's going to be. Now, if you are running multiple platforms, so say you have a Mac OS 11, iOS 14, iOS 12, whatever, there's the YOLO option. It quite literally is called YOLO because you only live once. It's going to run every single query, multiple modules, maybe they have 5 queries, it's going to run every single one of them. So it'll probably hit every platform, every version, but you're likely going to get redundant data. So just a heads up with that one too. But that's just throwing the kitchen sink at it. And then we have -K. And you can use -K or not. So that's going to extract a lot of the location data, which I'll show you in a little bit, and just output it to Kmz files so you can load those up into your favorite tool, things like Google Earth. And the modules directory again, and what directory to run it to. So if you did the gather, you want to use the gather directory. So temp Apollo, in this case, I've specifically renamed it to iOS 14. Because in my test data, I've got platforms and all sorts of fun stuff going on there. So once it goes through, it's going to parse all those modules. So in this particular version, I have 233 modules. Now, the databases may or may not exist for those modules. It does not really take that into account. And it doesn't necessarily say it's going to run more than one of those queries. So especially if you have the YOLO option, you'll notice that that modules is quite a bit larger. Just keep that in mind. So at the end of that extraction, so it's going to go run through all these different things, all the different modules. It's going to show you how many records are in each one. It's going to give you the total amount of those records, how many location records they are, and it's going to output it to, in this case, a SQLite database. If you chose CSV, it would be a tab delimited CSV. And if you did the -K, it's going to show those location records, and it's also going to output those Kmz files to the local, to the current working directory. So it splits it out by module, but perfectly honest, Wi-Fi location and ZRTCL location mode, that's fun to say. Those can be pretty large. I tried to bring mine up as an example, but it basically crashes Google Earth. There's just too many data points. So at some point, a future revision is probably going to split those out in some way, shape, or form. So I will show you another example of a smaller one of those output files in another slide. But for right now, we want to take a look at the Apollo database. All right, so we got this database, we loaded up. In this case, I am using DB browser for SQLite. It's got a lot of functionality, but it really just, it's just my preferred viewer for all of this data, for really any SQL data. So you bring in the Apollo database, and it's got one table called Apollo. not very creative with that one. As far as the different columns in this, and the CSV output is going to be pretty much the same. So just keep an eye out with that. We have the key timestamp here. So this is the timestamp that's in the module that says, this is how I want things sorted if I were looking from a timeline analysis standpoint. And standard, it's UTC. So all the SQL queries are extracting that as UTC, but I'll show you how to tweak that to local time a little bit in a couple slides. Activity, this is that human readable activity name. So if I'm browsing down, I can see that an application was installed, this app was being used, this location is being recorded, and so on. Now the output, this is where it differs a little bit. So my previous output version was the pipe delimited output, but I've recently introduced the JSON, which does make it look a little bit prettier, a little bit easier to read, but you have to have that other window open, at least for DB browser. Now your tools may be a little bit different, but this is how most of my screenshots are going to be for this section. Then we have the database. So this is going to show me what database it ran on. This one is particularly useful from a Mac OS standpoint if you have multiple user directories. So, user A versus user B, who did this particular thing. That's a nice little way to be able to filter. And then finally, module. So it's going to show me what module ran on what database and what query set it ran on. So all of these different fields, and I specifically like DB browser because I can filter on all of these different things, or I can build these into my SQL queries. Which brings us to what's better, using those filters or querying it? It honestly doesn't matter. It's going to get you to that same point. So if you love SQL queries, go ahead and run those SQL queries. If you have a tool that does great filtering like DB browser, use that. I actually end up using that filtering tool because it's faster. But if you end up running some of the same queries on the Apollo database, saving those off can also be pretty darn useful. So in this case, I'm literally just sorting by the day here. I can use the filter options up here, but I can also do the same thing in the query. So it's a choose your own adventure. Which one do you prefer? Now to change that to local time, I am normally a UTC or GTFO type of person, trust me on this, but when I'm trying to do rapid testing and I'm trying something over and over, gathering and then extracting and just looking for a little bit of set of data, what it looks like, I want that in local time. I don't want to have to do some time zone math. I can barely figure out what month it is anymore, let alone what day, what time zone, anything like that. So a couple of different pieces here that I like. Again, DB browser. They have this edit display format, which you can customize, which is really cool. Change that to local time. And you can do the same thing over here within your SQL query using date and time function. So again, whichever path you choose, you can normalize this data to local time. All right, so starting to actually get into some of the queries. You're going to notice, and you probably didn't see it in a previous screenshot because I'm just kind of banging these out. But this particular extraction was 2.7 million entries. This was an iOS device. This is a test iOS device. You can certainly have many, many, many more entries, but 2.7 is a lot to go through. So one of the first things that you might want to do is remove some of the noise. And you can do that in a few ways. You may not necessarily need all of those different queries. There are some queries in there that get down to very specific, very granular detail that you just may not care about. Well, you can use DB browser to filter those. So set filter expression not containing. You'll see that in a couple of screenshots in a little bit. Or you could do the not process them at all. Because it's modular, just extract those text files from the modules. Then it just won't process them at all. So if you just say, I don't know what this is, half the time I don't know what it is because I'm doing research on it, just remove it. And then you could also just create your own custom query. So if I don't really have any queries for third-party app data. That's just way too much, honestly, for myself. Apple keeps me very busy just doing the native set of information. You want to add in Twitter information or Slack or whatever app that you may be looking at. You have a query for that. Create a module and just run that in there. So you just plop that into the modules directory and run that just fine. And hey, while you're at it, maybe submit it into the Apollo data set. Happy to accept PRs, help a fellow investigator. That work is critical. It doesn't, it takes a lot of work to build a query. Help other people out. Sharing is caring, I think, is what Brian said a little bit earlier on. All right, now let's get into some of the removing of the noise. And again, I'm just using the filters here. So we started out with 2.7 million events. If I filtered down to a particular day, so a certain event I'm investigating happened on November 16th, 2020. If I do that, that brings it down to 145,000. And then I'm going to filter out some of the noise. So some of the information, these queries, not necessarily always going to be useful in every investigation. So with that, and I'm extracting some of those or removing some of those up here, that filters that down to still 36,000 entries, which is still a lot. It quite literally acts as a log file with the timestamping here. So there's a lot of information that can be extracted. All right, now a few things. So now we're actually getting into the queries. So you may have a certain event. Sarah was observed getting into her vehicle. Okay, so what modules have vehicle things associated with that? CarPlay. If you know my car has CarPlay, it does. You're probably going to be looking for CarPlay connections, which not surprisingly gets recorded for whatever reason. So in knowledge, see, disconnects or CarPlay connects and disconnects do get recorded. So I'm going to filter by module here, and it's going to show me all these different statuses, and I'm going to look at the output. So this output shows me that CarPlay was connected and for how long. So about 11 minutes or so. All right, that's great. What if I don't use CarPlay, or what if I, just don't plug it in or don't just disconnect it? There's other ways of getting access to this data. Now, one thing you may see here, if you're looking at the timestamps, is a connection. This one is a disconnection. You can see that information in there. So I was doing something for about 61 minutes. And then we see another connection. Now, I'm not showing you the output there, but just bear with me, it is another connection. One thing we don't see here is the disconnect. Why? Computers act strange. You're going to find that a lot of data that you should get created, should get put into these databases. Sometimes it misses some, sometimes it gets it twice. So kind of bear that in mind, keep that in mind. But just know that even if I do not get that one particular entry, I can literally find like 12 others that's going to show me very similar information. That's the great thing about all of this data. So if I didn't have CarPlay, or for whatever reason that last disconnect didn't work out, I'm going to go bounce to another module output. In this case, motion state history. This one is part of location D services, and it is quite literally keeping track of, is the device moving or not? Is it in a vehicle? Oops. Is it mounted, which I believe is if you're on a bike or not. Have yet to test that one. And all of that information. So I can see, and if I just follow these down, I can see if it's in a vehicle, then outside the vehicle. And it's actually a pretty good detection. As far as I've seen tracking my own movements, it's pretty darn close, like scary close how accurate that actually is. But plenty of other indicators. Now, next thing, where the heck did I go? Well, we're going to use location information for that one. So I got some routine D locations. So routine D is the best location data that you're going to get off of an iOS device. I should say a lot of the iOS specific data that I'm talking about here is going to be your full file system dump. So you're not going to generally get most of this data in your normal iTunes backup. All the juicy stuff, you have to work a little bit extra for that. So you have to use your magical black boxes to get access to a lot of this data, or jailbreak the device. So routine D, a couple of different, I think that one has about 10 different queries for it, give or take. And it comes with a different table set here. So I'm going to key off of that CarPlay connection, and I'm going to look at where did I start? So that's the closest location to that one, and I can plot that one out, and potentially one where it ended. So I can basically literally plot the entire path to my device. Now, these are constantly being created. So ZRTCL location mode, that's the best table. This is keeping extremely granular location data on a per second basis. Look at those timestamps. It's recording every single second. Now the kicker here is that it doesn't stick around forever. So it stays around for about a week. It gets maybe populated into a few other databases selectively, and then it's gone from the device. So if location is part of your investigations, you need to get to that data as soon as humanly possible because it's going to go away in a week. So you, with this routine D data, quite literally follow a path of where I was at any particular moment in time, or where the device was at any point in time. So if I look at the output for some of these, I'm going to extract the coordinates here. So I've done some SQL query magic and threw those together. So you could quickly copy those out and paste them into something like Google Maps. So it just makes it easier to sort of pinpoint all those different things. But if I have 40,000 data points, which is not uncommon on a normal working device, you probably don't want to do that over and over and over again. So that's when we're going to go to the Kmz files. So in this particular instance, I made my way to a local park. Now those Kmz files, again, each one is a different module. Each one has different granularity. Some are more granular than others. Some have a different data retention period. So also keep that in mind. I'm going to specifically look at the routine cache ZRT hint.mo Kmz file. The names are very interesting, but they come from the SQLite database. I did not make them up, so you can't blame me for some of those. So I opened those up, and this one actually opens up in Google Earth, and you can actually see my path. So it does have the timestamping information in here. I live over in Arlington, just outside of DC, in this nice populated area over here. And I kind of went over here, then down here, then down here, and down here. Now, this was not all vehicle traffic. Some of this was me walking. Now, we're going to take a closer look at that a little bit, just to kind of extract more information. So first thing, I want to know, what the heck was I doing in the park? All right, what apps did I use? Well, I'm going to filter here on the activity. App is usually a pretty good one for this, and I've even filtered it down even more with Knowledge C. So what application in focus, some of the usage information. So this one is app in focus. It says I'm using the camera application. How was it launched? iOS keeps these nice little details in here. So I did a lock screen scroll instead of just going to the springboard and launching it. And you can see some of the usage information. So how long was I using the camera application? Pretty useful information. I also used podcasts, music, video, Zoom video, as well as mobile SMS. So all these have timestamps and usage and all sorts of other details. So I see podcasts and music. Maybe I want to go take a look at some audio Bluetooth information. So a pretty good one would be to look at the activity for Bluetooth. And this is going to pop up a few different types of modules, but I'm going to look specifically at the connected items here. So I see the name of the device, my AirPods Pro. Those are my AirPods. Not, again, a very creative name. It also shows me usage time. So like I'm in the park for about an hour or so, it shows me that I'm using those also for about an hour. So what am I listening to? Well, a few more modules for those. In this case, I'm using playing here to filter on what's playing. Literally almost everything that you're playing gets recorded in here too. So I was listening to Phil Morris, This Week in Forensics podcast, catching up. And if I select one of these now playing, I can see some of the media information, some of the metadata information associated with that, and how long I was listening to it for. So we got about 11 minutes right there. Few other examples. Music here, in this case I'm listening to Cruella, but the one thing here is the usage. So 2 seconds. So this is me skipping songs. You know, I have this idea called short attention span radio, like just clicking different songs until I find the one that I'm in the mood for. And then another one is Zoom. All right, so some applications do not necessarily keep track of all that metadata information. That's unfortunate, but it does show me usage information. So maybe I want to go figure out who the heck am I Zooming with. So I'm going to look within context. So I break out some of my filters and maybe look a little bit before, a little bit after to try to get some hints on here. So a little bit before, I have an application intents. So intents is going to provide more context to what an application usage is. In this case, I'm using the Twitter application. This group ID here has my Twitter handle in it, I am Evil Twin. And it also shows this class here, direct message conversation. This is showing me that I'm doing something in a direct message, sliding into somebody's DMs, if you will. And if you open up this data blob here, so a lot of data blobs are going to get stored in this data. They're usually very highly nested binary p-lists, protobufs, gzips with protobufs and binary p-lists. Kind of gets to be pretty insane. But if we extract that and review that, lo and behold, I was Zooming with Brian. You saw him a little bit earlier on. Now, to verify that, you would probably want to go to application data. So Zoom data, Twitter data to verify that. Apollo is not currently extracting that. I really don't want to do third-party apps. You can certainly go ahead and create those if you choose. You'll notice that Lee, as I was getting the screenshot, my friend Lee Lipfield was messaging me about something in my SANS class. So let's see what that looks like. All right, Lee. So Lee slid into my Zoom session, and we have a couple of different indicators here, SMS chat and notification. So under SMS chat shows the message here, it's iMessage, his contact information, message date, and when I eventually actually read his message, about 15 minutes later, sorry, Lee. And then finally the mobile SMS and the notification that it was received. So you can see it, but I didn't necessarily read it at that particular time. And lo and behold, I was in the park for a specific reason. I wasn't finding a place to hide my bodies, dead bodies and all that, gory stuff. I was just there to go take a walk. I just needed to get my deeper fit on. And we have this whole health database, which I haven't even begun to dig into as far as this presentation is concerned, but it is the largest database. Mine is about 1 gig in size. Literally every heart rate that I've had for like the last 8 years, whenever the first Apple Watch came out, is being stored in this database. So I see that I started a workout on my Apple Watch and all the metadata associated with that. And one more before I end the presentation, so I am nearly almost done here, is what about other devices? Well, if you are a Apple nerd like I am, you have the whole ecosystem of devices. I have multiple laptops, iPads, iPhones, TVs, HomePods. I have the whole system. A lot of these devices will sync to other devices. So if you only, from an investigative standpoint, have one single device, in this case an iPhone, you can still potentially see some items that I did on my laptop or my iPad or my other iPad or my other iPad in there. So you can usually search for the hardware UUID here. So this 502 is the hardware UUID for my laptop, one of my laptops, and see things like screen time. What was I browsing through Safari Web? Notifications to those devices. So I see that I'm not, not surprisingly, I was on Twitter. I'm always on Twitter. It's probably not healthy at this point, but I am on Twitter, the name of my device. And you can also see that I was browsing news, Apple News on that particular device for about 4.5 minutes. So it's not even just that device itself, it's everything in the ecosystem. If it's all interconnected through your Apple ID. And I'm guessing that's it for me. So I'm just gonna go ahead and skip to this. Thank you for attending. Sorry, I'm sure we don't have enough time for too many questions, but just a few other things. I do plan on doing a blog series called the Apollo Diaries. So little small vignettes on all of this information so I can get into a little bit more in-depth information. Feel free to contact me with any questions. I'm easy to get a hold of on Twitter. If you got BlackBag, Blacklight has Apollo modules built in the plugin section, which is pretty cool. Thank you to everybody whose data I use, whether willingly or unwillingly. My friends here, they always get sucked up into my own data. And my Forensics 518 class, if you are interested in diving into more of this stuff, come take it with me. All right, thank you.
Well, thank you very much, Sarah. Thank you. I'm assuming there's a virtual applause going on Discord right now. Thank you for all that. There's a lot of stuff on there and a lot of artifacts to pull out. And there's a lot of exciting stuff in there. I did see some comment of people wanting an extension on the autopsy module deadline to make some wrappers around these things or to get some more stuff in. So it's very exciting. So thank you again, Sarah. We are running out of time. Harlan has a video coming out after this. We knew it was shorter, so we gave Sarah a little extra more time to make sure she could cover all of the great information that she has on there. So Sarah will be in the Discord channel to answer whatever questions you have. So thanks again, Sarah.